Heading: Lead-acid battery. First point. A lead-acid battery is a rechargeable secondary battery that converts chemical energy into electrical energy. Second point. It uses lead dioxide as the positive plate, sponge lead as the negative plate, and dilute sulfuric acid as the electrolyte. Third point. It is widely used in automobiles, UPS systems, and power backup applications. Draw diagram. Heading: Important parts of lead-acid battery. Side heading: Container. First point. The container holds all the battery components. Second point. It is made of hard rubber or plastic and is resistant to acid. Side heading: Plates. First point. The positive plates are made of lead dioxide and the negative plates are made of sponge lead. Second point. These plates take part in the chemical reaction to produce electricity. Side heading: Separator. First point. The separator is placed between positive and negative plates. Second point. It prevents short circuit while allowing the electrolyte to pass through. Side heading: Electrolyte. First point. The electrolyte is a mixture of sulfuric acid and distilled water. Second point. It conducts ions between the plates during charging and discharging. Side heading: Battery cover. First point. The battery cover seals the top of the container. Second point. It protects the internal parts from dust and leakage. Side heading: Vent caps. First point. Vent caps allow gases produced during charging to escape safely. Second point. They also provide access for checking and filling electrolyte. Side heading: Intercell connector. First point. The intercell connector connects individual cells in series. Second point. It helps to obtain the required battery voltage. Side heading: Cell terminals. First point. Cell terminals are the positive and negative output connections. Second point. They connect the battery to the external circuit. Heading: Working principle of lead-acid cell. First point. The lead-acid battery works on the principle of electrochemical reaction. Second point. During discharging, chemical energy is converted into electrical energy. Third point. During charging, electrical energy is converted back into chemical energy. Draw diagram. Heading: Chemical action during discharging. First point. Lead dioxide of the positive plate and sponge lead of the negative plate react with sulfuric acid. Second point. Both plates are converted into lead sulfate. Third point. Water is formed and the concentration of sulfuric acid decreases. Fourth point. Electrical energy is supplied to the external circuit. Heading: Chemical action during recharging. First point. An external DC supply is connected to the battery. Second point. Lead sulfate on both plates is converted back into lead dioxide and sponge lead. Third point. Sulfuric acid concentration increases as charging continues. Fourth point. Chemical energy is stored again in the battery. Heading: Maintenance of lead-acid battery. First point. Check the electrolyte level regularly and add only distilled water if required. Second point. Keep the battery clean and dry. Third point. Clean the terminals and remove corrosion. Fourth point. Ensure that vent caps are clean and not blocked. Fifth point. Recharge the battery before it becomes completely discharged. Sixth point. Check terminal connections and tighten them properly. Heading: Advantages of lead-acid battery. First point: low initial cost. Second point: high current output. Third point: simple construction. Fourth point: reliable and easy to recharge. Fifth point: widely available and easy to maintain. Heading: disadvantages of lead-acid battery. First point: heavy and bulky. Second point: requires regular maintenance. Third point: shorter life compared to lithium-ion batteries. Fourth point: contains corrosive sulfuric acid. Fifth point: charging takes more time. Heading: applications of lead-acid battery. First point: used in automobiles for starting, lighting, and ignition. Second point: used in UPS and inverter systems. Third point: used in emergency lighting systems. Fourth point: used in substations and power backup systems. Fifth point: used in solar energy storage systems.